Product rule can also work with sets. But a couple of interesting things when we talk about sets here. Now, the set size can be whatever you want, and they're going to talk about a Cartesian, which means our result will have an ordered pair to that. And that's the interesting part about this when it comes to sets. So 1 and 6 does not equal 6 and 1 if we were just to have a set of two values. Very distinct and very different when it comes to that, to sets. One of the big rules that you actually saw before is, remember that the bars mean the number of elements in that particular set. But what's going to happen is that your product rule is going to have, really, honestly, it's going to be the multiplicate, all of the values, putting all those sets together is the breakup of each set being multiplied to each other. And you really kind of saw that, frankly, in the last exercises before we got into sets. But now you might see some items that are in sets that you know how to handle, which really shouldn't be super hard. So that's the good news. But you may, this is basically telling you, you might see some sets here, and order does matter when it comes to sets. Here is your next item. This one's going to be a little bit more interesting. To be honest with you, I would wait till you see some of the other items that were coming up. I'm not saying that you're going to use any of the items that are coming up, but some of them have some similarities. You're like, okay, maybe I can frame it this way because this should be using the product rule, but hold on these for now and come back to this. How about that? And then we can go over a solution for these.